Hi everyone, it's Mr. Barden here. Today I'm going to be going over with a slightly longer video, I'll just tell you that right now, that's going to be all about making one of the projects in the course I teach, a game called Bug Squish. It's very creative, you can probably guess what we do. Before we hop into that though, if you learn something, you enjoy the video as we're going through it, definitely consider liking and subscribing to the channel. It definitely helps out with all of that stuff. Also, if you have any questions about anything I do, definitely put those in the comments. I love responding to those, and I'm actually going to have a specific prompt for you all to maybe try a few things, assuming I remember when we get to this. It's all going to be off the cuff. But I've got a question planned for you all towards the end, so be ready for that. Okay. So, just to briefly give you an idea of what we're going to be doing, I've got the textbook for this course. Like everything else, I'll have it linked down below in the description. But in the graphics unit, the last thing we do is make a game. And this game is very simple. It takes a little bit of everything we've done and we use it, and we have to click and squish as many bugs as possible before the end of the game. And the more you get, the better you do, and so on. And once you click all of them, more of them show up, so it'll go for as long as possible. This version was done using an older version of p5play. I'm going to specifically be going over how we did it this year in my class with the newly released version here with p5play version 3.0. So I'm just going to copy some stuff here. Yoink, copy that because I'm going to need it. So I'm just going to have this kind of up, ready to go, just in case we run into any issues, but definitely check out all of that. Let's head back into P5, and this is actually a fresh sketch, so I just need to add the lines into the HTML document that will let us look at p5play, and that's what's going on right here. I've got videos on how to do all of the things that I'm going to talk about today on the channel, and I'll be putting little cards periodically throughout this on the top of the screen. So if you see something you're not a little bit sure about, definitely check that out. I'll also have a playlist in the description with all of the videos. Okay, that was a lot of setup. Let's actually, for real, start coding. So the first thing I want to do is be able to see the bugs I'm going to squish. I want to be able to put them on the screen and actually see what's going on. So I'm going to real quickly just make a folder to hold all the images that's going to go on the thing. Images. And we're going to create that. And I'm just going to, from right here in the textbook, you can actually, if you just go to the additional resources, and sprite images and sprite sheets, all of the images for this assignment are right here. So I'm just gonna real quickly save image as and the last one. There we go. All right. So I'm just going to hop right back over to here into my images folder, and I'm going to upload those files. We can do it like this because it'll pop up with my most recently selected ones. So you... One... 2, 3, and 4, the squished one. And there they all are. So one thing I'm going to do real quick with these is I'm actually going to rename my images here, and I'm going to make them all restart at 0. So 0, 1, 2, and 3. I'll explain why I'm doing this in just a moment when we start loading all of these up. 3. There we go. I just realized I was kind of hunched down. I'm just on a laptop on my desk at the moment, so my camera is not in the normal spot, and I was like, my back hurts. I'm getting old. All right, something like that. So we've got all of the images that we're going to need right here. I'm going to pull up with function preload just to load up all of these, and we'll just get this done real quick out of the way nice and soon. So I'm going to declare all of this globally just so that way we can talk to it in the various other functions. So let's see, let background image, that'll be one, and we'll say bug sprite, we'll say bug images. It's going to be an empty array. And then while I'm at it, I'll go ahead and we'll say bug and all bugs. We'll start with that for now. So I'm declaring a bunch of stuff that we're going to use. We're going to start with the images and then move to the sprite. So background image is going to be, we're going to load an image right there, and we just have to tell it where to find the image. So that's in the imag images folder / background.jpeg right there. Boom. The next thing I'm going to do is actually make a for loop. And again, I'm just going to use the for loop in order to load up, wrong button, a bunch of images all at once. So we'll say let I equals 0, I is less than 4, I plus plus. So this is why I wanted to rename my images and have them start at 0, so I could just very easily use a for loop without having to, remember weird stuff or do conversions and things like that, or just do repetitive code. So I can just say bug images, but specifically index I, whatever that's on, is going to be load image, and we're going to look at the images folder / bug sprite underscore. Then we're going to say plus whatever value I is plus .png, just like that. And then what this will do is this will find all of the images, and since the address is the same for all of them except for this number, we're just going to update whatever that number is each time. And if we load this up, we shouldn't run into any issues. We ran into an issue. Let's see, where can't it find it? So it can't find the one we have there. So Bug Sprite 1, Bug Sprite 2, 3, 4. So just the bug sprites, not the that. It's always weird stuff like this that we run into, which is why I'm kind of doing this live. It's kind of fun to see all the things that are popping up. So for some reason, we can't find those images. So images, yeah, that one's fine. / bug sprite. If I got rid of the underscore, maybe. I've done that before and haven't run into issues. Trying different stuff. Just make sure that gets saved. And yeah, that worked. I think, honestly, what I think happened is that not all of this had updated in the P5 server, but also just getting rid of that underscore fixed that, so now all the code is running. Okay. So we've got the images I'm going to use. I'm going to take my background, and we're just going to display background image here. I'm going to make the canvas bigger, just so there's more room to play. And there it is. That's there. And generally speaking, we won't really need preload for the rest of this. So what I like to do, I'm just going to close that. What I like to do is to make one sprite that's going to work, for all of our bugs. And then once I know we've got that one working properly, then, it'll all work and we can just, copy and paste, essentially. So I've got bug and all bugs. I think we're also going to want... let's say rotation angles, just for funsies. And these are going to be specifically 0, 90, 180, and p5play likes to use -90 instead of 270, so whatever. Save that. We're also, just while I'm thinking of sprites, we're going to need one for the walls. Actually, we'll call this one top wall, bottom wall, left wall, and right wall. So we've got all of that there. I'm just trying to think without going and looking at my cheat sheet. Right now, we'll come back up here if we need to. So I'm just going to tidy that up and save it. And let's go to making a sprite. So I'm going to go into my setup function where I do this. And I'll just, I'll do this. So we're literally going to copy and paste this into another function by the time we're done. So I'm going to call mine bug, and it's going to be a new sprite. And I'll just put it right in the middle of the canvas. Right to this doesn't matter because we're going to be adding animations to it. So let's just go ahead and quickly add the animations. So, I should name these. I'll call it alive and squished. There we are. So alive is going to be bug dot add Annie. So we're going to add the animation. We have to give it a label. Again, I'm going to call it alive. We have to tell it what images we want to use. So what I'm going to use is the ones from up above, bug images, just like so. But we're going to look at a specific one. I'll tell you right now, we're going to need 4 of them. So 1, 2, 3, 4. Change that to the G. And if I remember right, we should need 0, 1, 0, 2. If I remember right, because basically we have animation frames of the bug with its legs going straight out, one with them up like this, one with them up like that. So we have to repeat a frame in the middle of that in order to keep things going smoothly. If we run this, there we go. We have that right there. I'm going to just add dead. So dead equals bug dot add equals bug dot add Annie dead bug images right there. Tidy, save, run, and now we see the dead one right there. So I'm just gonna swap this, or we could just say bug dot Annie equals alive. We could just do it like that. And in fact, that's what I'll do. Because again, our sprites can only display one at a time. So you can, whatever the last one was, that's what's going to pop up as the default, and you can either set it to be something else with this label we give them, or you can just change the order that you've added them. That's up to y'all. Okay, so now we're going to set the bugs rotation. If you recall back from the example I played, they were moving all over the place. And we want that to happen. We don't want them all to be facing weird directions or all moving in the same direction. So I'm going to do that. I'm going to real quickly do something beforehand, though. And we'll say bug... I call it all bugs. All bugs, capital B, bugs, equals a new group. I can call it all bugs, right? Yes. So we'll be essentially talking to all of the bugs here. All bugs dot add this bug. So basically we're going to make a group so we can talk to all of the bugs at one time. And the reason I'm going to do that is so we can say bug dot overlap all bugs. So anything with that all bugs group name there, so all of the bugs are bugs, I know this is very hard to follow sentence, are going to overlap with each other on the screen. Normally, sprites will collide off, and that normally wouldn't be too much of an issue, except that when we're just going to be spawning a bunch of the bugs, they're all going to, appear on the screen, and if they're going to be pushing each other in weird directions, then this next part's not going to work. So we had to add that right there, but we'll just say bug.rotation equals random from the rotation angles. Right there, and just to be extra redundant, we'll say floor all of that. And basically that's just, again, just a lot of times the sprites will overlap and bump each other ever so slightly. So when we make this conditional right here, if bug dot actually, let's do this a little differently. Let's do it with a switch instead. Basically, we're just going to be looking at what the bug's rotation is and making it move in a direction at that point. So let's do it as a switch, actually. That's fun. Switch, and then we'll have bug dot rotation we'll say it's case 0, and then we'll have a thing, and we'll say break. Then we'll have case 90 break. Case 180 break. And then case -90 break. And last but not least, we'll have a default. I think that needs a break at the end. So basically, we're just gonna, what this is gonna do is it's gonna switch. It's gonna see what bug.rotation is, and then we will, respond accordingly. So if it's 0, then we will say bug.move, where we're gonna have it move. So if we haven't rotated it all, the bug's still pointing up, so we want it to move up. So we'll say move up at a speed of, I don't know, we'll just say 3. And I like to pick something absurdly large. So we'll say for 80,000 pixels. And I'm going to copy and paste all of this. For the default, I just wanted to say bug dot rotation gets assigned 0, and then the same thing happens. So if for whatever reason there's a bug that's not pointing up, down, left, or right, we're just going to make it point up and make it move. But now if it's rotated 90 degrees, now it's moving towards 3 o'clock, so we'll move that to the left. 180 is down, and I got that wrong, that's to the right. And then at negative 90, we will be moving. I got one too many copy paste there. We'll be moving to the left, and this shouldn't be here. There we are. So if we save this and refresh it, the bug should not be moving properly. Okay. Okay. So it, for some reason, it's moving down when it's doing it, down and to the right. So why? So if it's moving to, it's been rotated 90 degrees, it should be going to the right, like that. See, this does weird things every now and then. We're going to leave it for now, and we'll come back in just a moment, because I'm not sure why that was misbehaving, because that should all be doing its thing. Again, there's only one instance where it's going to move down, and that's if it's rotated 180 degrees, and it was obviously not rotated 180 degrees. So I'm not sure what's going on with that case. Something's a little off, but we're just going to keep going. All right, so we've got that set up. What we're going to do next is set it up so that way when we click the sprite, the animation changes. So what I'm going to do is, this is going to be happening in the draw function, most of it. And we're actually going to be doing a fair bit of stuff in here, so I'll open up a bit of space, but we'll say all bugs dot for each. And basically this just means all bugs, the group, it's basically just an array. And we're just going to do the same thing for all of them. And what that'll be is a function e. Just do that, and basically we'll just say e dot mouse dot pressed. That's what we're going to be checking for. So we have to add that into a if that is true, then we'll do this. E dot change and E dot Annie equals dead. Actually, we'll say this. If is dead is equal to false, then we'll say E dot is dead equals true. So what I'm doing right here, I realize I've been talking for a second, or writing without actually talking a whole lot, is, again, making just a little function with no name, and we're just going to run it every time, we're going to essentially run it every frame. And basically we're going to look at all the bugs, and we're going to say if the mouse is currently pressing on the bug, then we're going to check and see this, and that is the bug already dead? So if it's not already dead, we're going to then make it dead, change the animation to dead, e dot velocity dot x equals 0, e dot velocity dot y equals 0. We're going to make it stop moving because it's dead. And then see what else. We will say e dot life equals 60. Make it disappear after 1 second. Score will go up. Let me go ahead and just make a thing called score here. Score, because we're going to need that. Score plus plus. So that's all happening right there. And then the last thing is I'm just going to say, we'll put this not in this outer conditional, but still in the, the if it's pressed, we'll say if all bugs dot size returns or sorry, not that, if it's less than 1, then we're gonna make more bugs. I'm just gonna call that more bugs. And let's just say I like doing things randomly. A random number between 5 and 50. And just to be safe, we'll say floor, just because I know that can get a little confusing sometimes. Tidy all that up. So this is what's going to happen every time we click a bug, essentially. It's this little conditional right here. That's going to live in the draw function, but we're going to be adding a bunch of stuff around it. Before I forget, though, because I know I'm going to get an issue, I'm going to make a function called more bugs, and we'll come back to that later. Because this is what we're going to move all of the sprite stuff into once, we're doing it. So now if we click this, it didn't go. Why aren't you going? Why didn't that go? I can just do it all sprites. See if that changes. Why aren't you changing? Oh, I remember why. Duh. Because I never added a property. So, I've now made the sprite, and I'm gonna just, real quickly just say, do bug dot is dead equals false. We had to make that property, and now I click it, it squishes. There we go. Okay. So that's most of the bug stuff working. So actually what I'm going to do is two things. That bug was a little big for the screen. So after we've set the animation, we can then just say bug.scale equals 0.5 to make it smaller. There we are. So we're going to do that, and then I'm going to take all of this section right here. Scroll down a bit more. Right there. Copy. Remove it. And inside of 4 bugs, we're going to use it. So, or more bugs. What I like to do, I like to make a specific number of bugs. So we're going to say, we're going to run a for loop. We're going to say let I equal 0, I for as long as it's less than the number, and then I plus plus every time. We're going to run that, only instead of putting it in the same spot, we are going to stick them randomly, and I usually stick them, about 50 pixels from the edge of the screen in all directions. 57, 50. I got those numbers because I set the canvas to 800 by 800 up here. So that's that right there. So now we have a way of making as many bugs as we want to make, which is very, very handy. So let's start now by making the the structure of the game. I can tell you a few things we're going to need in setup. We have to make sure that the score starts at 0. It's kind of important. The game time, how many seconds, can be, I usually do 30 seconds. And then the game state should be start. There we are, and we just need to add to our list game time and game state. Let's just tidy that up and save it. All right, so what we're going to be doing is monitoring this variable called game state and then having our draw function react to that in different ways. So if I go into the draw function, after we put the background on, we'll say if, and you could do this with a switch as well if you wanted to. I just felt like since we use a switch for the other thing, we'll use a conditional here. Game state is equal to start, then we're going to do something. Else if game state is equal to play, else if game state is equal to end, we'll do a third thing. So what we're going to be doing now is making the start screen, the playing screen, and the ending screen. I like to do it with functions. So we'll say if the game state is start, we're going to run function start screen. And if it's end, we're going to run function end screen. These are going to be essentially identical functions. So I'm just going to scroll all the way to the bottom. Function start screen and function end screen. You one thing I think that you could definitely do, this is one of my hey, pay attention for it, you might want to work it out yourself, is you can make just a single function to handle both of these screens. And you could definitely do that. I don't think it would be terribly hard, but give that one a shot and see what might you come up with for a way to make just a a function that puts an image on the the menu on the screen, but can also go away. So what I like to do for these is we'll say push and pop, just that way graphic things don't fight with each other. And I'm going to have my start screen. I'm just going to put a gray rectangle on the canvas. So we'll say fill. I'm just going to be easy and do gray like that. A rectangle width divided by 2 minus, let's make it pretty big. So I'll say minus 300 height divided by 2 divided by 2 minus make it half as tall, and then we'll make it, to double those numbers, 600 by 300, just like that. That should work. Just getting comfortable. My feet are falling asleep. And we're gonna keep going. I want this to have a thicker outline, so stroke will be 0 and stroke, and stroke weight will be 5. Why not? Maybe I'll make this a little gets narrower, just like that. All right. So now for the text, we're going to say this. We'll say no stroke, because that'll look weird. Fill black, and then text. So this is where we're going to say what we want to say. So I'm going to make this a string. I like using the kind of, what is this, the little template strings right here with the tick, because for a lot of these we'll be looking into variables and wanting just to display that as a string. This will make life a little easier. So we'll say click the bugs to clear the infestation. You could either hit the enter key, or if you just do the /n to make a new line, either one works. Click as many as you can in 30 seconds. Good luck. Whatever we want to say right there. So we also need to tell it where to go. So I'll just say width divided by 2, height divided by 2, and we'll say text align center as well. Now if we run this, there's the text. That looks a little small, so we can just say text size 20. Maybe we'll go 25. And we'll just scooch it up by about 30 pixels. Sure, that's fine. And I'm going to take all of this and copy and paste it into end screen as well. The only thing we're going to change is what pops up. So we'll say time is up. New line. You squished. Now we're going to look inside of a variable. So we're going to say $, curly braces, the name of the variable, that many bugs, new line, press return to play again. And we'll see this later as we go, but again, this is just going to look inside of whatever the player score is and display it on the screen. You can do the same thing with game time, but that's up to you. So that's all right there. There's draw. So one thing, I'm going to go ahead and move it there. This function that we made to tell the sprites how to respond to being clicked, we can just put that inside of the play state, because we're only ever going to need it whenever the game is being played. If we're not playing it, we don't need to check. So another thing we're going to need right here is to tell the computer, tell the game how we're going to move from each section. And we can do that just by saying if and having a nested conditional. So we'll say if the mouse is pressed, then we will do a few things. We will run more bugs, and we'll just say we'll make 20 bugs to start with every time. We will also we will say, I gotta double check my math, but we're gonna set the timer here, and then we're going to do anything else. I think that's the most of it right there. So it's just whenever we're on the game state, we're going to click the mouse, and it's going to make 20 bucks. Oh, yes, the last one. We also have to then say game state gets set to the next one, which is play. If we don't have that, the game is never gonna actually work. So if it's play, we're gonna have a variety of things happen, but since we're kind of in that mode, I'm just gonna add the nested conditional statements. And if this one, it's gonna be if the timer is done. We haven't made the timer yet. So that's what we'll have right there. So if the timer is done, then we will, well, we're definitely going to say game state gets assigned end before I forget that again. But before that, we can say all bugs dot, we'll remove all the bugs from the screen. That'll go there, and then yeah, we do all the bits, and then we'll just say here at the end screen if key is pressed, and then if key code is equal to 13 for that enter key, then we will simply run the setup function. So boom, that's all right there. So I've just added a way to move from one state to the other. And when we get to the end, just by running setup again, we'll reset all of these values to be whatever we need. So we also need timer is done to equal false. And I'll make it up here. There we go. All right. So I'm thinking the next thing we'll do is add the little text to the screen, so that way whenever you're playing the game, you can actually, see what you need to know. So I'm gonna move this down, and we're just gonna come up with two text functions. Right there. If we wanted to, we could say push and pop, just that way the graphics don't fight with the other things right there. But we're going to say just simply needs to be the ticks like that, time remaining play time, that's what we'll call it, I guess. Anytime out of 30. I'll just put this at 100 for right now. Copy, paste, bugs, squished, $ bracket, score, close bracket. We'll just scoot this down a bit. Oh yeah, I didn't make playtime. That's part of the timer stuff. So we'll be hopping on that in just a moment. Playtime. And that's where those are. So, don't really like exactly that. So we're gonna adjust them. So we'll say text size equal, there's text size 15, why not? And we'll put this at 30, 50, and 30, 70. Why not? We'll see what that looks like. That'll work for this. So we haven't actually done anything with the timer yet, so that's why it says undefined. But if we click the bugs, we should hopefully see. Why aren't you clicking? Well, now they aren't clicking, but we'll figure that out in a moment. Timer, yes. So I've got a little cheat sheet to help me with the timer. If we go into graphics right here, because I remember the math, I just never feel like remembering the math. We're going to tweak this one that I have here for this. So we've already got most of the bits right here. So I'm just going to copy this whole thing right there. Copy, paste. So let's see, we'll have whoop-a-doo. I call it start time. No, I called it play time. Play time. Game time. Game time. And game time. So I was just updating this to be the appropriate variables to match what's going on right here. Basically, we're just gonna, every time we call this function, we're gonna say, hey, what is the whatever this playtime is whenever we started it, and we're gonna compare that against however many milliseconds have run since the sketch began. We're going to then divide all that by 1,000 and just round off the number because it's a pain to count time using milliseconds in a practical sense. And then if it's past the threshold of 30 seconds, we're going to set the timer is done to true, and that's what's going to cause this to automatically pop up down up here whenever the timer is done is true. You can even say true if I could type, but if you wanted to be extra clear. So what we'll be doing is this. When we set this, we will say play time gets assigned to be the result of the millisecond function. And then in the play state, every frame we have to call the timer function right there. So we'll just be updating and resetting playtime, and it'll just automatically adjust the timer. So if we run this again, we should see that was not right. Okay, how do we get to that? I haven't run into this issue before, but it swapped. So, and now it's that. Okay. What are we displaying on the text? I mean, oh yeah, we don't want playtime. We want game time, I think. There we go. So now that's doing the bugs. I don't think are still being clicked, which I'm not liking. So we'll still come back to that as we go. Okay. So what's next? We're almost there, actually. We have to basically make a set of walls to keep the bugs from disappearing. So I do it like this. There's a ton of different ways to do it. This is my second, what would you do in the video? And, think of maybe a potentially easier way to go about this. I'd love to see what you all are doing. So function walls. So we're just going to say, we made this before at the very beginning, but top wall is going to be a sprite. Bottom wall is going to be a new sprite. It's going to be a new sprite. Left wall and right wall. There and there. So I'm basically going to be positioning these around the screen, but off of it, so that way we can set it up so that way whenever a sprite collides with it, then it will teleport the sprite back to where it should be. So I'm going to start with the top, and that's going to go right in the middle of the canvas. I'm going to set it at negative 150, and then we'll say we'll make it, what is it, width wide, and we'll just make it 30 arbitrarily tall. So that's one. The bottom wall is going to be the exact same, except it will be height plus 150. I'm just going to copy and paste some of that. Actually, no, I'm not going to do any of it. So for the one on the left, we're going to go at negative 150. And then we're going to stick it at height divided by 2 to get that in the middle of the canvas. And then it's still going to be, 30, and then height pixels tall. Copy, paste, and now we are going to width plus 150 right there. The next thing I'm going to do is just say top wall dot collider gets set to, I can always keep doing that, static. I'm going to do that for all 4 of them. And what this will mean is just that, the sprites will still detect collisions, but the sprite here won't update. So this way, we can have the bugs respond to it without the walls getting moved. There we go. So we'll set all that to static. Now, we have to set up the collisions, and I'm going to do it by making the functions first. So I'm going to make a function that's going to teleport someone in a particular direction. So to the top of the screen, and we'll just say item dot x, or just going to we're teleporting to the top. Yeah, so x equal, no, this should be y. What am I doing? Got y equals negative 100. I just want it to be less than the walls. That way none of the bugs go past the walls. And I'm basically just going to be, we'll also just say item dot move, and let's say item dot rotation equals, if we want it to go down, that's 180. Item dot move down on the screen, because we teleported to the top at a speed of 3, and at for again something absurdly large, 80,000 pixels. So what I'm doing is whenever a sprite comes in contact with the one on the bottom of the screen, it's going to get teleported to the top of the screen, but not past the other wall. And then I'm just going to, in case anything got weirdly aligned, reset the alignment and tell it to move again. And I'm going to copy and paste this in order to adjust it. So teleport to the top. Now we teleport to the bottom. And that'll make it y equals height plus 100. Rotation will be 0. And we move up. To teleport to the left, we want the x to be negative 100, rotation to be 90, and it will then move to the right. And then to move to the right, we need to say that the x is going to be height plus 100, rotation will be negative 90, and we will move it left. Okay, equals 0. So now we just need to set up the conditionals so that way the bugs can interact appropriately. So if I scroll back up to right here in the draw function, there we are. We'll just say boop, boop, boom, and we'll set all that up. We'll say all bugs dot collides, and we're gonna say when the top wall, then we're gonna teleport to the bottom wall, and we're going to copy and paste 2, 3, 4 top wall. When we contact the bottom wall, we teleport to the top. When we get to the left wall, we teleport to the wrong part of the word. Right. And when we get to the right wall, we teleport left. And that should make it so that way now none of these bugs will disappear, but something has somewhere gone wrong. That should be right wall here. I already made them. What do you mean? It must be a sprite or a group. They are. Oh. It's because I never actually made the wall. I made the function to make the walls, but we never actually did that. So in setup, we'll just run function walls right there. And now we're going. And some of this movement, again, is weird. But if you look, none of the bugs are disappearing. And now when I'm clicking on them, I don't know if my mouse is good for this. That one's squished. Why aren't the other ones squishing? Okay. Well, 29, 30. All right. So at that point, with the exception of, only one of the bugs squishing and a few of the directions being weird, it is working as for what it's supposed to be with my students. I'm gonna look a little bit, and I'm actually gonna combine. Save this, cancel, save this. We're actually gonna open the one that I made previously and compare it because this video has been going on for a bit. Here's the test one. Oh, I forgot. I did it slightly differently. But this is in the wrong spot. So we're going to take the all bugs.overlap all bugs, and I'm going to add that right here, just so that way the bugs keep overlapping each other, just to be safe. So if we run squish with E, I did that as a function instead. Function squish. I mean, I'll do it that way. So what I'm going to do, just because I know this has worked, is adjust my conditional statement right here. So all of this I already had. So I'm actually going to be deleting a fair bit of it. Everything right here, this inner conditional statement. And now instead of running all that stuff, we'll just say we'll run squish with that sprite. And then I'm going to scroll all the way to the bottom, make function squish, which was again, the same. I think literally the only difference was I made it 50 sprites right here. That's all right there. And then I just updated E to be item. But I noticed in that one, unless, no, something's, why is this one not squishing the bugs? Okay, they're not getting added to the group. Come here, more bugs. Well, no, all bugs dot add bug. I mean, I do usually stick that at the bottom, but I can't see that making a difference unless I'm not aware. No. Now, what if we just did this? Oh no, it is all sprites. Let's say all bugs. That one's squished. None of these other ones are squishing. I'm not sure why. This one uses e.mouse.pressed. This one that I know works uses... Should it not be pressed? Should it be presses? It's pressing. There we go. So this has some very, very interesting names. Oh, look. Bugs being squished. That was just the one typo. Most of them are working. There we go. You got to get kind of right on to click them. But we're going. I've now clicked all the bugs, or attempting to click all the bugs. They're super roaches. They don't want to die. But yeah, we got to like get right in the middle, which kind of makes it interesting. My mouse pad isn't good for that. But I think that's just about it. So this is, again, just kind of a walkthrough from start to finish. You know, I made it as quick as I could about the Bug Squish. My last kind of, you know, I would love if you came up with a way to do this. You know, again, the bugs not moving in the right direction. I have no idea what that's about. I would love to hear from you all about that. And then, you know, just ways that you would make your own twist on the game. I love seeing all that. So if you make your own, definitely put that in the comments below. I would love to check out everyone's games. And that's going to be it from me. Again, this is mostly just kind of a, you know, how-to for my students if they're needing to look at this after the fact. But hopefully someone, you know, someone else enjoyed and learned something. I'm going to be ending it here, so I will see you all the next time that I see you. Bye.